All right, so let's take a look at the types of reactions and what each of them look like. So this is just going to be a general form of the reaction. I'm not really going to go into any specific examples. You should be able to recognize some of them like just right away. But yeah, let's take a look. We're going to start with the synthesis, which is the first one that I mentioned. And it has the general form of A plus B make AB. So we have a single element plus another single element just combined together to make one compound. An example, I guess, would be H2 plus O2 make H2O. So this chemical reaction isn't balanced at all. So this isn't like the complete reaction, but that's just an idea. We have a single element of hydrogen plus a single element of oxygen combined to make H2O. Now decomposition is just the opposite. So we start with the complex compound and it breaks down to just its individual pieces. So we start out with the compound and we get each individual piece. So an example would be H2O breaks down into H2 plus O2. The next one is the single replacement or the single displacement, whatever you want to call it. But it looks sort of like this. We have an element plus a compound. And what's going to happen is the A and the B are going to switch places. So we're going to end up with something like that. And then B is just going to be an element on its own. So we have an element plus a compound they're going to switch into a different compound plus an element. Now we have the double replacement or the double displacement. And that's where we have a compound plus another compound. What's going to happen is the A and the C are going to switch places. So we are going to have, oh sorry, that should be the other way around. CB there we go, plus AD. So what happened was the A and the C switched partners, basically. That's what that looks like. Now the combustion reaction it has a very specific look to it because it involves oxygen, H2O, and CO2. So we have something like this. So X and Y are just different numbers. They can be any number. And what happens is they react with oxygen, which is O2, to create CO2 plus H2O. And remember, I'm not balancing any of these. You just want to look for the different elements involved. So if you see like CO2 plus H2O, that's going to be a combustion reaction no matter what. And then I wrote a sixth type of reaction called a neutralization reaction. I didn't talk about it in the video at all, but this reaction involves acids and bases. So we're going to have something that looks like this. So H with an element B is an acid plus OH. So this is oxygen and this is hydrogen. And when these two react, what happens is it's called neutralization. We have an acid and a base reacting, and we end up with AB plus H2O. So I'm not necessarily gonna ask you any questions about this one, but it's a good one to keep in mind, especially if we end up talking about acids and bases in general. So here are all the types of reactions again. So synthesis, is when two simple things combine into one. Decomposition is when we have one big thing that simplifies to simple pieces. Single displacement is when two of the elements switch spots on the other side. Double replacement or double displacement is when they swap partners with each other. So A went over here and C went over here on the reaction side. Combustion is a special type. We have some carbon-hydrogen compound reacts with oxygen to create CO2 and H2O, and these are always going to be the final products. And then we had a neutralization reaction where we had an acid and a base create this, which is called a salt, plus H2O. And again, you don't have to worry about that last one. I just wanted to bring it up just because. So that's it for this video. As always, if you guys have any questions, just let me know. But until next time, have a good one, guys. See you.